So let's let z be a complex number such that z plus 1 over z is equal to 2 times the cosine of 3 degrees. So we are to evaluate the absolute value of z to the power of 2000 plus 1 over z to the power of 2000. Now, since this is a complex numbers problem, you might be tempted to substitute a plus bi into z, or try to find a cycle, taking powers of z, but actually, my solution is going to be solving this with the quadratic equation. So we have z plus 1 over z is equal to 2 times the cosine of 3. So now multiplying everything by z will then give us z squared plus 1 is equal to 2 times the cosine of 3 times z. Then moving this over to the other side will then give us z squared minus 2 times the cosine of 3, z plus 1 is equal to 0. And then we can plug this into the quadratic equation. And so we get 2 times the cosine of 3 plus or minus the square root of 4 times the cosine squared of 3 minus 4 all divided by 2. And all this is equal to z. Now simplifying will then give us z is equal to the cosine of 3 plus or minus the square root of the cosine squared of 3 minus 1. And now remember from the Pythagorean identity, the sine squared of x plus the cosine squared of x is equal to 1 for all values x. Now rearranging gives us that the cosine squared of x minus 1 is equal to the negative sine squared of x. So then we can substitute the negative sine squared of x into the cosine squared of 3 minus 1. And so we get that z is equal to the cosine of 3 plus or minus I times the sine of 3. So now since there are two solutions to z, it doesn't matter which one you choose, you will get the same answer for this either way. So for simplicity, I'm going to choose the plus value. And so we're going to write z is equal to the cosine of 3 plus I times the sine of 3. So now I'm going to move this to the top, and then we're going to continue solving. So now we're going to use Demoivre's formula. Now recall that any complex number can be written in the form r times the cosine of theta plus I sine theta for some value r of theta. So Demoivre's formula states that this value taken to the power of some integer z is equal to r to the z times the cosine of z theta plus I times the sine of z theta. So now we can apply this to z to the power of 2000 and 1 over z to the power of 2000. Now 1 over z to the power of 2000 is equal to z to the power of negative 2000. And so we have z to the power of 2000 plus z to the power of negative 2000. And so we can apply Demoivre's formula to both. So z to the power of 2000 plus z to the power of negative 2000 is going to be equal to the cosine of 6000 plus the sine of 6000 plus the cosine of negative 6000 plus the sine of negative 6000. Now remember, the sine of negative x is equal to the negative sine of x, and so these two terms will cancel out. And so we have the cosine of 6000 plus the cosine of negative 6000. Now also recall that the cosine of negative x is equal to the cosine of x. And so this is then equal to 2 times the cosine of 6000. And now taking 6000 mod 360 will give us 2 times the cosine of 240. And so this is equal to 2 times the cosine of 240, which is equal to 2 times negative 1 over 2, which is equal to negative 1. And now the absolute value of negative 1 is then equal to positive 1, which is our answer, and we are done. Alright, thanks for watching, hopefully you enjoyed, and hopefully I'll see you next time.